Hello there. Welcome to my YouTube channel. Today I will take you through problems on the overall heat transfer coefficient. Let's tackle this question. The interior of a refrigerator having inside dimensions of 0.5 meters times 0.5 meters base area and 1 meter height is to be maintained at 6 degrees Celsius. The walls of the refrigerator are constructed of two mild steel sheets 3 mm thick of thermal conductivity K equals 46.5 watts per meter per degree Celsius with 50 mm of glass wool insulation of thermal conductivity K equals 0.046 watts per meter per degree Celsius between them. If the average heat transfer coefficients at the inner and outer surfaces are 11.6 watts per meter per square degree Celsius and 14.5 watts per meter per square degree Celsius respectively, calculate 1. The rate at which heat must be removed from the interior to maintain the specified temperature in the kitchen at 25 degrees Celsius. 2. The temperature on the outer surface of the metal sheet. Solution. Here is a diagrammatic view. Given thickness LA equals thickness LC which equals 0.003 meters. Thickness LB equals 0.05 meters. Thermal conductivity Ka equals thermal conductivity Kc which equals 46.5 watts per meter per degree Celsius. Thermal conductivity Kb equals 0.046 watts per meter per degree Celsius. Inside heat transfer coefficient Hi equals 11.6 watts per square meter per degree Celsius. Outside heat transfer coefficient Ho equals 14.5 watts per square meter per degree Celsius. Outside temperature TO equals 25 degrees Celsius. Inside temperature Ti equals 6 degrees Celsius. Finding the total area through which heat is coming into the refrigerator. Which equals 2.5 square meters. 1. Finding the rate of removal of heat, Q. Which equals 38.2 watts. 2. Finding the temperature at the outer surface of the metal sheet, T1. T1 equals 23.95 degrees Celsius.